Hi there. This video is an exam paper walkthrough of the Edexcel GCSE Mathematics Foundation Tier Paper 3 from summer 2023. This paper is worth 80 marks in total, and this is the fourth video of 4. It will focus on questions 22 to 28, which account for 21 of these marks. Edexcel Paper 3s are calculator papers, so a calculator should be used. A little disclaimer: there may be more than one way to answer a question. The methods shown in this video are not the only way some mathematical skills can be applied. Okay, let's get started. Question 22. ACF and ADG are straight lines. So ACF, ADG, straight lines. BCD and EFG are parallel lines and they're marked by these arrows here. Show that the triangle ACD is isosceles. So triangle ACD is this one here. And it wants us to give a reason for each stage of our working out. So what do we know about isosceles triangles? They have two sides the same, and then their base angles are the same. So we've not been given any information about the sides apart from their straight lines, or that we've got some parallel lines in there as well. So we can't actually use this fact, but we can use the fact that the base angles in an isosceles triangle are the same. So we would expect two angles within this triangle ACD to be exactly the same if it's isosceles. So let's work out what we can until we get to figuring out the angles inside this triangle. So the first thing I'm going to do is I'm going to do this angle here, FCD. So FCD equals, let's put angle FCD, so that's a symbol for angle. Angle FCD, so this is, you've got two parallel lines and we've got this Z shape here. So this angle and this angle are equal. So FCD is 125, and I'm putting it here and on my diagram because alternate angles are equal, okay, because of that Z shape. Now that I know this angle, I can find this angle, so angle ACD, because angles on a straight line add to 180, so 180 subtract 125 is 55, so this is 55, so angles on a straight line sum to 180 degrees. Okay. Now you can do this angle here for exactly the same reason. So angle ADC is 180 subtract 110, which is 70. So this is 70. So we're going to find out this missing angle. So the angle here, CAD, is 180 subtract 55 and 70 because it's a triangle, which is 55. So it's 55 there. We have to say angles in a triangle sum to 180 degrees because we've got to give these reasons. And now we've shown, so we can say here, two angles are equal, so triangle ACD is isosceles. We needed to find that third angle, didn't we, to figure that out. Question 23. It takes 14 hours for 5 identical pumps to fill a water tank. How many hours would it take 4 of these pumps to fill another water tank of the same size? Okay, so time and then pumps. So 14 hours for 5 pumps. We're aiming for 4 pumps, so let's figure out how long it would take 1 pump. So we're going to divide by 5. 14 divided by 5. So it would take 2 hours for 1 pump. We want to figure out how long it would take 4 of them then. So we're going to multiply by 4. So it'll take 11.2 hours for 4 pumps. Question 24. A and B are numbers such that A equals 2 squared multiplied by 3 to the power of 4 multiplied by 7. B equals 3 squared multiplied by 7 squared. So these are in product of prime factor form, okay, in index form. Part A, find the highest common factor of A and B. So to find the highest common factor, we're going to multiply all the common prime factors. So I'm just going to extend this out a little bit. So A is 2 times 2 for 2 squared, times 3 times 3 times 3 times 3, 4 of them for that power of 4, times 7. I'm going to expand B as well, so it's 3 times 3 times 7 times 7. And now what I'm going to do is I'm going to pull out what they have in common. So I can take a 3, I can take another 3, can't take any more 3s from B, so they have to stay where they are. I can take a 7 from each. So the highest common factor is 3 times 3 times 7, which is 63. So I'm going to put 63 here. Find the lowest common multiple of A and B. So the lowest common multiple is everything multiplied together, but these things here that we've taken out as the highest common factor, we only use them once. We don't use them twice as they appear in those lists. So we're going to do the highest common factor multiplied by what's left up here. So 63 times 2 times 2 times 3 times 3 times 7. $15,876. Question 25. Lava flows from a volcano at a constant rate of 11.9 meters cubed per second. So that's in seconds. How many days does it take for 67,205,600 meters cubed of lava to flow from the volcano? Give your answer correct to the nearest day. Okay, so first things first, we're going to divide this amount of lava by the rate at which it's flowing out. So 67,205,600 divided by 11.9. So 5647529.412. So that's how many seconds it's going to take for this lava to flow. So this is seconds. We want it in terms of days. So we need to go from seconds to minutes. So we would times by 60. Then we need to go from minutes to hours. We would times by 60 again. 60 seconds in a minute, 60 minutes in an hour. Then we need to go from hours to days. So we would times by 24 because there were 24 hours in a day. So we're going to do this sum in one big lump. We're going to do this that's still in our calculator, multiplied by 60, multiplied by 60, and multiplied by 24. So multiply by 60, multiply by 60. No, we're not. We're going to divide. Silly me. Way too big a number. So 5647529.412 divided. Silly me. Divide by 60. Divide by 60. And then divide by 24. So that is 65.36492,375 days. Okay. To the nearest day. So it's 65.3. That's 3 is less than 5, so it's not going to change it. So it's 65 days to the nearest day. Question 26. Here is a graph of y equals x squared, subtract 2x, subtract 2. So this is a quadratic graph. It's a positive x squared, so we've got this U shape here. Part A, write down the coordinates of the turning point of the graph y equals x squared, subtract 2x, subtract 2. So it's the same equation. The turning point is this point on the graph here where it starts to become symmetrical and reflects on itself. So we're going to read the coordinate of this turning point. So x first is 1, and then the y is -3. Write down an estimate for one of the roots of this quadratic, x squared subtract 2x subtract 2. So the root, so the turning point is the line of symmetry. The roots are on the x-axis, so where it crosses the x-axis. So here and here. So estimate for one of the roots. So we're just going to read off where we think it roughly is. So this one is 2.2468. So I'm going to go with roughly 2.8 there as an estimate. And it's an estimate because we haven't got an exact scale in there. Question 27. A solid cuboid is made of metal. The metal has a density of 9 grams per centimetre cubed and the volume of the cuboid is 72 centimetres cubed. Work out the mass. So density is the mass divided by the volume, but we want the mass, so we do density multiplied by the volume. So we're doing 9 multiplied by 72. So it's 648 grams because the density was in grams. Question 28, part A, write 9 times 10 to the power of 4 to 4.5 times 10 to the power of 6 in the form 1 to n where n is an integer. So we want it in the form 1 to n. So on this side of the ratio is the standard form 9 times 10 to the power of 4. On this side of the ratio is 4.5 times 10 to the power of 6. So this is the side of the ratio we want to be 1. So if we're going to make this 1, we're going to have to divide by 9 times 10 to the power of 4. So we're going to have to do the same on the other side. So it's division in standard form, it's just wrapped up in a slightly different package. So this is your standard form button here. Okay, so we're going to use that now. So we're going to write 4.5 times 10 to the power of 6, an arrow off, divided by 9 times 10 to the power of 4, which gives us a big number. Will it let us change it? No. So we can actually write that on our answer line. We don't need to, it doesn't say to convert it back to standard form. Just be careful with those number of zeros. Yeah? So let's write it 1 to 5, 1, 2, 3, 1, 2, 3, 1, 2, 3. Part B, write the following numbers in order of size. Start with the smallest number. So we want to figure out what these numbers are. So 5.625 times 10 to the power of 4 is 56,250. We already know what that is. Now this one, 56250 times 10 to the power of -3. Put 2 multiplication signs in there, that's not useful, which is 56.25. And then let's do this one. So it's 0.005625 times 10 to the power of 5. Remember, I was using my standard form button here, guys. 562.5. So now that they're all ordinary numbers, I'm going to write them in order of size. So smallest number first. This is my smallest number. 56 is smaller than 56,562 and 5625. So this is the number I'm going to write first, but I'm going to put it in standard form in its original form. So that's the smallest, done that one. The next one is this one. And then it's this one. And then last but not least.